Uncovering the mysteries of Bennu and a space news roundup. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. Scientists examining a sample of dirt retrieved from the asteroid Bennu found something quite surprising: traces of phosphate, a necessary building block for life to exist here on Earth. We'll speak with planetary scientist and leader of the OSIRIS-REx sample return mission, Dante Loretta, about how he discovered the phosphate in the sample and how it changes what we know about Bennu. Then, as NASA grapples with aging spacesuits on the International Space Station, efforts to build the next generation of suits hit a major snag. We'll speak with Eric Berger, senior space editor at Ars Technica, about the troubles with the spacesuits and other space news topics, like the continued delay of Starliner returning to Earth. That's ahead on Are We There Yet? The OSIRIS-REx spacecraft traveled over 1 billion miles to reach Bennu, an asteroid that sits between Earth and Mars and is billions of years old. The mission brought back samples that scientists have been studying to see what the asteroid is made of and if Bennu could answer questions about how life began on our planet. A surprising find of phosphate is bringing scientists closer to that understanding. Here to talk more about his findings and the asteroid's makeup is Dante Loretta, the leader of NASA's OSIRIS-REx asteroid sample return mission and Regents Professor of Planetary Science in the Lunar and Planetary Laboratory at the University of Arizona. Dante, welcome back to the show.
Thank you. It's great to be here.
So Dante, it's been a while since we've had you on the show. Since then, you and your team have gotten your hands on the sample from Bennu. A very exciting times for the team. You're digging into this 4.3 ounce pristine asteroid sample. And recently you found some very interesting findings within the sample, right? Tell me a bit about the phosphate that you were able to detect in this sample and why that's so significant.
We returned over twice as much material as we had promised NASA. We're really proud of that fact. So we were looking at around 2 ounces or 60 grams, and we brought back, as you said, 121 grams or over 4 ounces. And the sample is amazing in many different ways. And I want to take the listeners back to the asteroid encounter. And one of the big geology surprises there was some of the boulders have these big white veins. And by big, I mean about 1 meter or 3 feet long and 10 centimeters or maybe 4 inches thick. And that would never seen anything like that scale in a meteorite before. So we were like, wow. We wrote a paper in 2020 about it that Hannah Kaplan led. And our hypothesis was that we had large-scale hydrothermal activity in Bennu's precursor asteroid, right? Bennu is only 500 meters in diameter. It's in near-Earth space. It's most likely a fragment of a much larger asteroid that was shattered in the main asteroid belt. The idea that there might have been hydrothermal systems, think about the oceanic vents, these white smokers that we see coming out near the mid-ocean ridge. Those are the kinds of environments we were envisioning. So as we were picking through the sample, right away, one of the particles here at the University of Arizona in Tucson jumped out at me because the sample's really dark in general, but all of the images of the asteroid are stretched so you could really see the different features, and you don't appreciate how dark the material really is until you see it with your own eyes. But this one particle shone out as really bright and white. They're kind of speckled throughout the sample are these really white particles. And I thought immediately, that must be similar to the big veins that we saw on the asteroid. And we had spectral data that suggested those were carbonates, which are very common. Even in meteorites, we find carbonates, not at that size scale, but we still find them. And so I went in, I thought, oh, cool, we found the carbonate. And we got it in the electron microscope, and it was a phosphate. And I was like, that was completely unexpected. And I went to the American Geophysical Union in December last year and presented the first results. And I said to the audience, I've never seen anything like this before in meteorites. And my review of the geochemical literature isn't finding anything on Earth that looks like this phase. Not that phosphates are unusual, but this one's really rich in sodium and magnesium. And calcium is what you normally find with phosphates. And sure enough, one of the audience members, Fabian Klenner, came up and told me they found similar grains coming out of the plumes of Enceladus, which is one of the moons of Saturn. And it's famous for having these geysers that erupt into space and form the E-ring of Saturn. And I was like, this is really exciting.
Or what can that tell you about Bennu? I'm hearing things like hydrothermal, aqueous. Does that mean that Bennu may have come from a wet world?
Yes, absolutely. Bennu came from a wet world. The main minerals are these clay minerals, as we had predicted from our remote sensing observations. Those clays form at the hydrothermal vents in the oceanic crust of the Earth when seawater interacts with the mantle material. And the fact that we have the phosphate chemistry, we do see the carbonates, we do see iron oxides and iron sulfides, which are also characteristic of these systems. Absolutely, we're looking at some sort of hydrothermal alteration, whether it was an ocean world like Enceladus, which I've tossed out there and I think is feasible as a hypothesis right now, or maybe more of a muddy, squishy mud ball. We're still working through the details of that, but in any case, it had to have a lot of water and it was moving elements around. That's the other key thing about the phosphates is this pushes the composition well away from what a standard chondritic meteorite would be. And it's bringing in not only the phosphorus and the sodium, but also other fluid mobile elements like uranium and thorium. So we're seeing an interesting ancient fluvial system, maybe an ocean world, maybe something a little less extensive, but nevertheless moving elements around for millions of years.
Dante, I want to go back to the moment that you're in the lab and you're looking at this sample with your own eyes and you're spotting these specks that turn out to be this phosphate surprise in there. And I've got to imagine this really shows why getting your hands on a sample from Bennu was so important, right? This was not something that you would be able to see with remote sensing equipment, even one like the OSIRIS-REx spacecraft, right? You didn't catch this with the spacecraft while it was at the asteroid. You caught it while it was in your lab right in front of your eyes, right?
That's right. We never predicted the phosphates would be a major phase in the sample, and we did not see evidence for them spectrally. I still wonder, and we're doing this right now, did we miss it? Was it there and we just weren't thinking about phosphates? It wasn't part of our algorithm for processing the spectral data to identify the different minerals? And that's a great project that people are off investigating right now. But absolutely, the other thing about the phosphate, and we've got some really cool pictures. The first publication just came out last week in Meteoritics and Planetary Science, and it's fully open access, so anybody can go download it and take a look. And when you look at the phosphate, it's really just this thin, crusty, very fractured and friable layer that's sitting on top of the main rock type. And that would not survive passage through the Earth's atmosphere. So in addition to not seeing it with the remote sensing data, we also don't see it in our meteorite collections, probably because it doesn't survive passage through the atmosphere and has been lost to science until we were able to recover it directly from the surface of Bennu and protect it through atmospheric passage with that amazing sample return capsule.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Dante Loretta, the leader of NASA's OSIRIS-REx asteroid sample return mission and Regents Professor of Planetary Science in the Lunar and Planetary Laboratory at the University of Arizona, about what he found in the Bennu asteroid sample. Much like, why you're studying Bennu, right? This phosphate the asteroid itself has picked up all of these different materials as it moves through space and time, capturing the evidence of things that you're looking for, right? Signs of the early formation of our solar system and prebiotic life. What you found with this phosphate, does that get you any closer to the overall goal of this mission, which is finding that evidence of where we came from?
Yeah, I couldn't have been more excited that phosphorus was the element that surprised me, because my entree into the field of astrobiology was working on phosphorus chemistry. And we published what I consider now a classic paper in 2005, my graduate student, Matt Pasek, and I, where we're looking at corrosion of phosphorus-bearing minerals in meteorites to try to understand the kinds of chemistry, because phosphorus is so critical to life. First of all, it makes up the backbone of DNA and RNA, so it's central to our genetic material. It also makes the lipids that create cell membranes. And when you get to more advanced life forms like mammals, it makes our bones and teeth. So it's really important to understand where the phosphorus came from. And it's been a big mystery in astrobiology. To see that it was moving around in this fluid meant it's highly reactive. One of the next steps in our analysis is to start to understand what is the diversity of the organic chemistry that we're seeing. And we've always wondered, how do you get carbon and hydrocarbon to bond with phosphorus, and especially with phosphates? And now we see, well, you had a liquid where a lot of this stuff was floating around. So the opportunity to create something like a lipid, making a membrane, is really important. And one of the other pieces of information in that publication is the distribution of the carbon. And there's a figure that shows an example of a carbon nanoglobule. And we're just trying to figure out how to characterize these structures. But they look like little cells. They're spheres. They have a thick wall that's very rich in carbon. They're only hundreds of nanometers in size, so they're quite small, which is why we're still determining the best way to characterize them. But they look like one of the key steps towards the origin of life, which is compartmentalization. And I'm really itching to know, do those have phosphorus in that outer barrier that's separating the nanoglobule from its environment? Because that would really start to look like a phospholipid membrane if that was the case.
That begs the question then, Dante, did Bennu come from a place that could have once sustained life? Is that kind of the evidence that we're looking at right now?
We don't see any evidence of life in the Bennu samples right now, but we are talking potential environments like Enceladus. I mentioned it before, this crazy moon of Saturn, which has an ocean underneath its icy crust and is spewing out geysers into space. That's not an unreasonable model for what Bennu's parent asteroid looked like. First of all, one of the other things we report in the paper is the really high abundance of nitrogen, which has to mean that its parent formed in the outer solar system, because nitrogen doesn't form in ice until you get out to around the orbit of Saturn or so. So we had to have started out with this object deep in the outer solar system. It probably migrated to the asteroid belt where it was shattered and then delivered into the near Earth population. But when we think about places in the solar system where we hope we might find existing life, these ocean worlds like Europa and Enceladus are prime targets.
Fascinating. Dante, what's next? I mean, you haven't had your hands on these samples for very, very long. I can only imagine that the science is just going to get more intriguing at this point. What is the process moving forward when it comes to examining these samples even further?
Yeah, we have a big team, over 200 researchers all around the world. Here at Arizona, we have a lot of graduate students that are getting their hands on the sample and working on their PhD thesis. We're preparing a series of papers that are going to be led by my working group leads. So as the principal investigator, I took the right to publish the first paper. And my paper really kind of just outlines the nature of the collection with these cool surprises and sets the stage for all the more detailed studies that are coming. What we call our Wave 2 publications are in preparation right now. And once those are done, then the rest of the team will start to publish. And we have over 100 papers planned from the analysis of Bennu samples over the next year or so.
And finally, Dante, for the folks that don't read scientific journals, what do you want the general public to take away from this mission? This was a very highly publicized mission, a very exciting mission. But what does it mean for the regular people that are out there that may not be as entrenched in science and geology as you and your team?
Well, first of all, if you don't read science journals, but you do like to read memoir, I have a book out called The Asteroid Hunter, which chronicles my journey from a young, wide-eyed college student to there that day when we recovered the capsule in the Utah desert. With the OSIRIS-REx mission, we have a lot of different objectives. For me, and what we've talked about today, it's this idea of our origins. How did the Earth come to be a habitable world? Why do we have liquid oceans? It seems to be very rare in our solar system. There's only one other body, Titan, one of the moons of Saturn, that has liquid on its surface, and those are hydrocarbons like natural gas. So the Earth is clearly this beautiful, rare jewel where life took hold and evolved to produce us. We really want to know how that happened. First of all, just to understand ourselves and where we came from. But more importantly, how does it go in other places? Could Mars have had the origin of life? Europa, Enceladus, exoplanets. We want to know, are we alone? And these kinds of investigations help us understand that big question.
Dante, thanks so much for joining us.
Thank you.
That was Dante Loretta, the leader of NASA's OSIRIS-REx asteroid sample return mission and Regents Professor of Planetary Science in the Lunar and Planetary Laboratory at the University of Arizona. Still to come, spacesuits, Starliner, and a Space News Roundup. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. The International Space Station needs new spacesuits. 2 commercial companies signed on to develop new suits, both for the ISS and for missions to the moon and beyond. But one of those contractors has backed out. So what does that mean for the future of spacewalks at the space station? Eric Berger has been covering that story as well as other stories on the Space Beat. He's the senior space editor at Ars Technica and author of 2 books, Liftoff, about the rise of SpaceX, and his forthcoming book, Reentry, on the development of the Falcon 9 rocket and Dragon. Eric, welcome back to the show.
Thanks, Brendan.
You've done some reporting on spacesuits, the International Space Station, and spacesuits have been in the headlines quite frequently these past few weeks. Can you first tell us about what are some of the issues that are cropping up with the spacesuits that are on the ISS?
So spacesuits are really hard, and NASA has basically been using the same spacesuits that were developed 4 decades ago. First, they were used for spacewalks outside the space shuttle, and then now they're used for spacewalks outside the International Space Station for maintenance. Obviously, the design and the suits themselves are getting old. They're having some technical issues, maintenance issues with them. So NASA's been looking to get new suits, but the agency also wants to go back to the moon. And obviously, you need a different kind of a spacesuit on the lunar surface. And so NASA also needs new spacesuits for walking on the moon. And so after decades, for the first time, the agency really has to get serious about finding some new suits for astronauts to go outside.
And the spacesuit program, as you write recently in Ars Technica, just hit a major snag. Can you talk about what that snag is?
A couple of years ago, NASA, as it has been doing with a lot of its contracts, chose a commercial procurement path. So basically it went to the private industry and said, we don't want to buy spacesuits from you. We want to basically lease spacesuit services from you. So you would provide the spacesuits to us, we would use them, and then we would pay you for that service. And it chose 2 providers. It chose Axiom Space and Collins Aerospace. And it turned out that Axiom eventually was delegated to building the spacesuit to walk on the moon, and Collins Aerospace was tasked with building the spacesuit to operate outside the International Space Station, basically in space flight activities. And the snag is that Collins Aerospace held a meeting of its employees about 10 days ago now and said, we can't compete on this, and we're ending our participation as a spacesuit contractor. So NASA went from having 2 private companies building spacesuits to now just 1.
And as you mentioned, this is becoming an issue that is more timely by the day, as the spacesuits that are on the International Space Station now are 4-decade-old technology, and Collins was supposed to build the replacements to that. What does that mean for the future of ISS operations in both the short term now and the long term in the next few years?
One issue is that NASA probably is just going to limp along through the lifetime of the space station with its aging spacesuit technology. They've extended it for a couple of decades now. There's no reason to think they can't keep flying these suits from their 5 or 6 years with an intensive maintenance program. These spacesuits go up on Dragon and other vehicles. They come back down to Earth. They're worked on and they're sent back up. So they probably can't extend the lifetime. And the other thing this does is it really puts the onus on Axiom Space, the other provider, which is based here in Houston, to build not just the lunar spacesuit, but also modify it for operating in space on the International Space Station. Now, Axiom tells me that they have a plan for that and they're working on it, but it really is a pretty significant concern to me because it completely removes your redundancy.
Was the focus on Axiom from the get-go just to work on those lunar suits, and now they've got to switch gears and kind of tackle it from 2 different angles? As you mentioned, they're 2 different suits with 2 different needs. That's got to add a lot of pressure to one particular private contractor, right?
They delegated the spacesuit, the lunar suit to Axiom, and the in-space spacesuit to Collins about a year ago. And so they've been working on divergent paths. But I'm told that Axiom does have a plan to modify its lunar suit. The other thing we haven't talked about is that NASA is facing extraordinary pressure to land astronauts on the moon, right? They have the current timeline of 2026, which really doesn't seem reasonable. But one of the major tentpoles in that is the spacesuit, right? And so there's a lot of pressure on Axiom. And so you can't really go to them and say, hey, I know you have this really high priority for a lunar spacesuit, but also we have a really high priority for an in-space suit.
Eric, as we've seen, there have been some cancellations of spacewalks because of these suit issues. Are some of these issues that we're seeing with the current spacesuits, are they going to affect that? And how does that impact the operation of the International Space Station in the coming months?
NASA did have plans to complete 3 spacewalks this summer in June and July, and now they're down to 1. And the reason for that is, one, there was due to an astronaut had a suit discomfort issue, and then later on, they actually got into the airlock and had opened the hatch, and there was a water leak of the spacesuit. My understanding is that these issues primarily are not due to the aging spacesuits, but rather perhaps a preparation issue prior to the spacewalk. But NASA hasn't really been clear about that. So it's hard to really parse that. But I don't think you can get around the fact that the current suits are aging and large and a bit clunky and difficult.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Eric Berger, senior space editor at Ars Technica and author of 2 books, Liftoff, about the rise of SpaceX, and Re-Entry, on the development of the Falcon 9 rocket and Dragon. We've been speaking about spacesuit issues on the International Space Station, Eric, but I'd like to chat about some other issues on the International Space Station, and that includes Starliner. The crew remains on the International Space Station with Starliner docked to it with no return date set. Can you bring us up to speed on what's going on with the Starliner mission?
Yeah, so Starliner has now been at the space station for a full month. Originally, it was a 10-day mission, and then it was extended a couple of times. NASA set return dates and then pulled those back, and now has left it open-ended. As you may recall, 1 helium leak and then eventually 5. I don't think this is the major issue that NASA is concerned about at this point. They seem to have the leak issue under control for now. The bigger problem is that 5 of the 28 RCS thrusters, so these are small thrusters that help maintain position and attitude of the vehicle, pretty critical for maneuvering. They're not the big, powerful thrusters, provide a lot of the oomph, but they sort of keep Starliner pointed in the direction that it's supposed to go. They were able to recover 4 of those 5, but they didn't really understand the root cause of the failure. And so instead of undocking from the space station and coming home, when they will need the use of those RCS thrusters, NASA and Boeing have decided to put a couple of those thrusters on a test stand in White Sands, New Mexico, and begin test firing them and trying to replicate the failures that they've observed while the spacecraft was traveling to the space station. That work is likely to unfold over the next couple of weeks. And then if they solve the problem, then I think they'll clear spacecraft to come home pretty quickly thereafter, perhaps before the end of this month. If it's a little more tricky and they don't quite get to the root cause for whatever reason, then I think they're going to want to study it a little longer, and they could push Starliner's return even into the month of August.
Eric, the initial conversations around these thrusters was that it could possibly be a software issue, which is why they were turning themselves off or not working properly. But the fact that they are physically looking at testing these thrusters down here on Earth, does that kind of change the outlook of what the issue may be? Could it be more of a mechanical issue now?
I asked at a press conference several weeks ago about the very issue, and the answer was that it was not a hardware issue and it was not a software issue. And so, at that point I was wondering, is it a spiritual issue? I wasn't sure exactly what that meant. But the fact that they are trying to replicate the failure on the ground suggests to me that it could be either or. They just don't really know for sure yet and would like to understand the problem.
There has been news coverage that the astronauts are stranded. They're not able to get a ride back. That is not the case, says both Boeing and NASA. But the fact that there's not a return date set, does that give you any pause, or should that be cause for concern from folks that are following this mission?
I'm not too concerned. Fact of the matter is, NASA said pretty clearly that they could come home in an emergency situation. So let's say like some space debris hits the space station and it's uninhabitable and the crews all have to evacuate. Butch Wilmore and Sonny Williams would get inside Starliner and fly back to Earth in that scenario. The reality is that when it's docked to the space station, Starliner is a perfectly safe configuration. It's not leaking helium. They're not firing the thrusters. They basically have powered the vehicle down. And so they're pretty confident in its ability to stay up there a couple of months. So I think they're trying to take this time to just make sure they really understand this problem. Because let's face it, if they were to fly back or to undock from the space station and then this thruster problem occurred again, only it was worse, they would really be in trouble because the crew would have difficulty getting back to the space station. There might be some problem with reentry. That seems like a very low likelihood probability, but I think NASA wants to make sure that's a probability of 0.
Right, because you're going to lose that evidence, right? These thrusters are on the service module and they're going to burn up in the atmosphere. The only testing they can do on them is at the station, right?
Starliner spacecraft has 2 main components. You've got the crew capsule where the astronauts live, and then you've got the service module where there's a majority of the power and propulsion systems that move the vehicle. And right before the spacecraft enters the atmosphere, the service module separates, it burns up, and the crew capsule obviously has a heat shield, and it's designed to re-enter safely. And so those thrusters are all going to be lost. They will not be recovered. And so NASA wants to study them while they can.
This is a critical test mission for the Starliner program to certify it for operational missions. It's too soon to have a definitive answer to this, Eric, but with the issues that we're seeing with Starliner and this test mission, do we expect that there are going to be delays in getting Starliner ready for operational missions once Butch and Sonny are home and they're able to parse through all that data?
I think that's a fair bet, because it's a little bit embarrassing for NASA, my view, that the previous flights, the second uncrewed test flight of Starliner, had very similar thruster issues. They've had almost 2 years to look at that flight and assess them. And then they flew the vehicle, and very similar thruster issues occurred. They're going to really want to lock down that problem before an operational mission of Starliner. Now, the next opportunity for that would be in the February of 2025 timeframe. NASA hasn't decided whether that will be a SpaceX Dragon mission or a Boeing Starliner. My strong suspicion is that that's a SpaceX mission, that the earliest operational mission of Starliner would be 12 to 14 months from now, at least.
And finally, Eric, just switching gears, but still sticking with the International Space Station, SpaceX was awarded the contract to deorbit the International Space Station. Tell me a bit about the contract and what this means for the future of the ISS.
So the International Space Station is it's the largest thing humans ever built in space. And if you were just to let it re-enter on its own and come back to Earth, it would be uncontrolled. And there's a very much non-zero chance that crash into land, that large chunks of it would survive, and that if it hit a city or a suburb or a reasonably developed area, it would cause significant damage. Lives would be at risk. So NASA does not want to have an uncontrolled reentry of the space station. It had a couple options. One, it could have tried to push the space station to a much higher orbit where it never would reenter. That would require way too much energy. It would have been extremely expensive to do that and maybe not even feasible. They also looked at breaking apart the space station into smaller chunks for reentry, but that again was considered to be too difficult. So the most straightforward approach that NASA came up with was having a special one-off mission to basically fly a spacecraft or propulsion module up to the station, dock it for about a year, and then guide it on a controlled reentry and probably splash it down, in a remote area of the Pacific Ocean around sometime in 2030. And so they awarded a contract recently. SpaceX won the contract for about $800 million to do a modified Dragon spacecraft and complete that mission.
And do we know when that mission will occur?
The SpaceX launch would be in 2029. So that's the U.S. deorbit vehicle is what they're calling it. It would dock to the space station for about 12 months. The last cruise would leave, and then that vehicle would bring Splash Station down sometime in 2030.
We've been speaking with Eric Berger. He's a senior space editor at Ars Technica. He's the author of 2 books, Liftoff, about the rise of SpaceX, and his forthcoming book, Reentry, on the development of the Falcon 9 rocket and Dragon. Eric, thanks so much for joining us.
It's my pleasure, Brendan. Thank you.
That's going to do it for this week's show. If you're not already, be sure to subscribe to this show's podcast feed so you never miss an episode. Do that on Apple Podcasts, NPR, Spotify, YouTube, or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. If you got an idea for a future episode of this show, or you want to join us as a guest, reach out to us. We're at awty@cfpublic.org. And we've got more space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marian Summerall. Our intern is Sophie Diaz. Editorial guidance from Latoya Dennis. Support from Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.